Hi, my name is Stephen McGee and I'm the author of Toxic Health. We're here today to look into atmospheric turbulence and lensing around clouds. And to do this we have a very simple opaque block of glass that you can buy in the hardware shop. And these blocks are actually used in bathrooms typically to give privacy. But they actually provide us with an excellent model to see what goes on with light and how it comes down and passes through and creates these lensing effects. As you can see, we've got some shadowy patches, we've got the area where the light actually falls, and then this is the block, and then this is the lensing effects that this block is actually creating. And as you can see, some very high-powered lensing going on with this block. And we have a standard laser pointer. And we're going to shine it through the block and we're going to see what actually happens with the light as it passes through the block. And the reason why we're doing this is because these effects occur around solar power systems. And clouds can do it, and cirrus can do it, and turbulence, believe it or not, can do it. So if you get a lot of turbulent air, you may be getting these bright patches of light underneath as the sun passes through it. So let's see what happens when we shine our laser pointer through it. So as you can see, the laser pointer has magnification effects, and sometimes it expands out, sometimes it compresses. Now, the expanding out isn't too bad, but the compression of the light into a spot is very concerning, because if you've got some turbulence or clouds over a solar power system and they compress the light into a very tiny space, you'll find that you may actually blow all the fuses on your solar power system. So if you're having problems with fuses blowing on solar power systems, you should be aware of this effect that occurs with the atmosphere and become familiar with it. It's actually, in the industry, it's known as the cloud effect, but it also occurs around turbulence. And turbulence can occur above solar power plants simply because of the heat that is generated from the solar power plant. Solar power plants only have an efficiency of somewhere between 10 and 15% normally. So the rest of that loss of efficiency, the other 85%, gets turned into heat generally. So you end up with a heat haze over solar power systems that can actually generate this compression and expansion effect on the light that passes through the turbulence. And if you're having blowing fuses and you can't trace it to anything on the system, you should start looking into atmospheric effects, and particularly, look around your system and see whether there's any chimneys in the area or any large buildings that can be causing turbulence to occur. And even smoke in the atmosphere will do this. So if you have a solar power system in a very industrialized area, you may actually find that the atmosphere starts generating these turbulence effects that can compress and expand the light as it goes through the atmosphere. So there you have it. Something to be aware of around solar power plants is lensing of light through atmospheric turbulence and layers and clouds. I hope you enjoyed this presentation, and I wish you the very best of health. Thank you.